Hi Year 4. So we're at the end of a week of learning how to tell the time in our maths work, and I don't know about you, but I found it pretty tricky. Telling the time is really hard, and there are lots of different skills that you have to understand to do with analog, digital, how many minutes in the hour, all of these tricky skills, 24-hour, 12-hour. So whatever you've managed to achieve this week, be really proud of yourself. It's one of the trickiest skills we do in maths, so it will have been even harder for you if you've been learning it at home. So well done, and well done to your teachers too. At the end of the week, we always do some problem solving. So that's adding an extra challenge to you. And we're also at the end of a long term, and it's been the strangest term that I've ever had in my teaching career, and I'm sure it's been the strangest term you've ever had in your pupil career. So problem solving is a really tricky thing to ask you to do, because it needs your brain to be fresh and it needs your brain to be excited, and none of us have got fresh or excited brains at the moment. So I'm going to work through the problem that we've put on our website together with you, and I will give you opportunity to solve it along with me, and we'll try and achieve this together. Let's give it a go. So here's the problem on our webpage. It says Miss Copeland's watch loses 2 minutes every hour. Oh no. Okay, so her watch is not working very well, and every hour it gets 2 minutes further behind. Mrs. Pettifer's watch gains 1 minute every hour. Oh dear. So my watch is going too fast, and every hour I'm getting an extra minute. We both set our watches at 6 a.m. and start our journeys to school, and when we arrive at the same time as each other, our watches are 10 minutes apart. But at what time did we arrive at school? So our watches have ended up looking 10 minutes apart, but we've actually arrived at the same time as each other. What time is that? Okay, I think we need a strategy to solve this. We need to be systematic, and we need to write a table. Okay, to be systematic with this problem, I have set out a table with 4 headings. We want to know the actual time. We want to know what Miss Copeland's watch is saying, and hers loses 2 minutes every hour. And we want to know what Mrs. Pettifer's watch is saying, and hers gains 1 minute every hour. And then to solve the problem, to answer the question that's set in the problem, we need to know when that difference meets 10 minutes. And when the difference between these two times is 10 minutes, that will be the actual time that we both arrived at school. So the problem says that they both set their watches at 6 a.m. So when the real time was 6 a.m, Miss Copeland set her watch for 6 a.m. as well. She set it correct, and I did too. So that's the real time, and our watches are correct at the moment because we've just set them. So what is the difference between 6 a.m. and 6 a.m? Nothing. They're exactly the same. There is no difference in time between our watches. So far, so good. Now, an hour passes. 7 o'clock. But Miss Copeland's watch doesn't say 7 o'clock. It's 2 minutes slower than that. So remembering that there are 60 minutes in a whole hour, and we're 2 minutes behind 7 a.m, what is Miss Copeland's watch going to say? Remember, there aren't 100 minutes in an hour, so you can't say something 98. There are 60 minutes, and we're taking off 2 of them. Hopefully you've had time to have a go. By the way, what I'd love you to do is pause this video if you haven't already and set your own table out so that you can be trying to beat me to the answers. So pause this video, write down what we've got so far, and then come back and put your answer in here. So 2 minutes behind 7 a.m. going to be 6:58 because we're 2 minutes slow. It's still AM, it's still in the morning, but her watch is 2 minutes slow. My watch, however, is 1 minute fast. So it's not 7 AM in my watch. It's gone 1 minute further than that. So you write down what time you think my watch is going to say. 1 minute faster than the real time. Well done. 7:01 AM. Now to our difference. There is a difference between these two times now. We've got 2 minutes behind the hour and 1 minute ahead of the hour. So how many minutes difference is that in total? How many minutes would it take to get from 6:58, 6:59, 7:01? How many minutes passed between those two? Well done if you've got 3 minutes. Put my unit of measurement properly. So far, so good. Remember, we're trying to solve a problem to find what time the watches show 10 minutes difference. So we're not there yet, we've got to keep going. Let's have a look at 8 o'clock. Now, I bet one or two of you think, oh, it's going to be 7:58. But have a think carefully about why that's not correct. We lose an extra 2 minutes each hour. If we wrote that it was 7:58, we wouldn't have lost any time. Her watch would have magically fixed itself. But it's broken. Every hour it's losing another 2 minutes. So think carefully what another 2 minutes off this time is. And remembering that we've gone a whole hour in real life. You have a go. So we're now at 7:56. Well done if you got the 56. Well done if you also got the 7. We lost 2 minutes there, and we lost another 2 minutes there. So that's in total 4 minutes slower than it should be. Right, let's move over to my watch. My watch is gaining a minute every hour. So it went from 6, an hour later, 7:01, an hour later, and a minute gained. What time are we going to have? Try and beat me to it, please. An hour's passed and an extra minute's been added on. Don't just wait for me to do it. Write your answer down, even if it's wrong. A guess is better than nothing. And if you got 8:02, you are correct. Now, what's our difference? How many minutes between 7:56 and 8:02? 7:56, 57, 58, 59, 60, 1, 2. How many minutes did we have between those times? You put your answer down first, no cheating. 6 minutes is correct. Right, so we're still not 10 minutes apart. We're looking for the actual time when our clocks show 10 minutes difference. So let's try 9 o'clock. Because we're getting there, we're getting nearer to 10 minutes, so we're on the right lines. So again, an hour is passed, but we've lost another 2 minutes. So an hour has definitely passed, but we've lost 2 minutes. Pause the video if you need time to think or talk it through with a family member. Do not wait for me to give you the answer. Beat me to it. Okay, hopefully you got the same as me. An hour's definitely gone past, and another 2 minutes have been lost. Over to Mrs. Pettifer's watch, to my watch. An hour's passed, but we've gained a minute. You should have the hang of this by now. Pause the video if you need to. An hour has passed, and we've gained another minute. Now, there's two things you could do here. You could count our difference like we have been doing, or you could try to see if there is a pattern forming. Let's do both. So how many minutes between 8:54, 55, 56, 57, 58, 59, 60, 1, 2, 3. How many minutes between 8:54 and 9:03? Hopefully you've got 9 minutes. That's an interesting pattern. 0, 3, 6, 9. What are we counting in there? Very interesting. Let's do one more. 10 a.m. An hour has passed. We've lost another 2 minutes. You write your answer down. We've gone up 1 hour and down another 2 minutes. In this one, we've gone up 1 hour and up 1 minute. You first. Okay, let's calculate the difference between those. 52, 53, 54, 55, 56, 57, 58, 59, 60, 1, 2, 3, 4. How many minutes between those two? And does it fit our pattern? I'm waiting for you. Well done. 12 minutes. Right, we've definitely got a pattern, but if we look back to our original problem, we wanted to know what the time was when these clocks were 10 minutes apart. And we're not going to get a 10 if we're counting in threes, because 10 is not in the 3 times table. 10 minutes apart is somewhere between these two. Oh, that's very interesting. 10 minutes apart is somewhere between those 2 times. Right, let's have a close look at this. Let's put where 10 minutes would be. 9, 10, 11, 12. There's 3 minutes between them. 1, 2, 3. We want to be a third of the way between 9 and 10. 1/3, 2/3, the whole way. So we need a fraction of that time. 10 minutes will be exactly a third of the way between 9 a.m. and 10 a.m. 1/3, 2/3, 3/3. Well, it would have been easier if it was halfway between, then it would have been 9:30. It would have been useful if it was a quarter of a way between, then it would have been 9:15, because that's quarter past. But we want our 60 minutes dividing into 3 chunks. What's 60 divided by 3? Well, we know what 6 divided by 3 is. So we must know what 60 divided by 3 is. It's going to be 20 minutes. So we want our clocks to be 10 minutes apart, which is a third of the way through this time. We know that 20 minutes is a third of an hour, So our answer's going to be 9:20. We got to school at 9:20 a.m. and our clocks, the slow one and the fast one, were 10 minutes apart. 9:20, oh my goodness, we're late for school. That's no good. You guys have already started basic skills by 9:20. If only our watches had worked. Now, here's a GDS challenge for you. And I will admit here, my brain got to the point where it couldn't cope with this challenge. So please don't worry if yours can't either. I wonder what this clock said. A third of the way between that time and that time. And I wonder what this clock said, a third of the way between that time and that time. That would be a real one to work out. But well done. I'm really proud of us. And I'm really proud of how we have turned our problem-solving brains on, even though that is particularly challenging right now. Well done, Year 4. Fabulous work.